Have you ever wondered how large companies keep their HR files completely separate from their finance systems, even though all those computers are plugged into the same office network? The answer is something called a VLAN, and by the end of this video, you're going to understand exactly how it works. Welcome to 3V Learning Center. I'm Sarah, and this is part of our Cybersecurity for Beginners series. Whether you're studying for your Network Plus, your Security Plus, or you're just curious about how networks are built, this one's for you. Let's get into it. Let's start with a problem. Imagine your company has one big office with 60 computers, HR, finance, IT, all plugged into the same network switch. Here's the issue. On a basic network like this, every device can see every other device's traffic. Your HR computer is technically on the same network as the intern's laptop. Finance data flying around? Visible to anyone with the right tools. That's a security nightmare. Now, a VLAN, which stands for Virtual Local Area Network, fixes exactly this problem. A VLAN adds invisible walls to your network. It splits one physical network into multiple separate logical networks without buying extra hardware. Think of it like an apartment building. One building, same hallways, same elevator. But each floor is a completely separate apartment. The people on floor 2 cannot walk into floor 3's space. VLANs do the same thing to your network, in software. Here's something really important, and this trips up a lot of beginners. A VLAN does not require extra cables. It does not require extra switches. It's a logical separation, not a physical one. Look at this. One switch. One piece of hardware. But with VLANs configured, it behaves like 3 completely separate networks at the same time. VLAN 10 for HR, VLAN 20 for finance, VLAN 30 for IT. The devices on VLAN 10 cannot directly communicate with devices on VLAN 20, even if they're sitting next to each other physically, plugged into the same switch. This is what we mean by logical, rather than physical separation. The network exists in software and configuration, not in the cables. The switch creates these separate networks, but how does it actually know which packet belongs to which VLAN? The answer is tagging. When a device sends data, the switch reads which port it came in on. It then attaches a tiny label, called a VLAN tag, to the packet before forwarding it. Think of it like a color-coded visitor badge in a building. Green badge, finance floor only. Red badge, HR only. The standard that defines how this works is called IEEE 802.1Q, pronounced 802.1Q. You will see this name constantly in networking and security certifications. Remember it. What 802.1Q does is add a 4-byte label to every packet. The switch reads this label and only forwards the packet to ports that belong to the same VLAN. Without the matching tag, the packet is blocked. End of story. There are 2 types of connections on a VLAN-capable switch, and they do completely different jobs. First, the access port. An access port connects to an end device, a computer, a printer, a phone. It belongs to exactly one VLAN. The device plugged in doesn't even know VLANs exist. The switch handles all the tagging behind the scenes. Second, the trunk port. A trunk port connects switches to each other, or a switch to a router. It carries traffic from multiple VLANs simultaneously. All packets traveling through a trunk port are tagged. Here's how to remember it. Access port. 1 VLAN, 1 device, no tags needed. Trunk port. Many VLANs, many tags, carries everything. In a real office, your computers plug into access ports. Your switches connect to each other and to your router through trunk ports. Let's pull this together with a real-world example. Imagine a university. 3 departments share the same building and same network infrastructure. Human resources, VLAN 10. Finance, VLAN 20. IT, VLAN 30. When an HR employee sends a file, it goes to the switch through an access port. The switch stamps a VLAN 10 tag on the packet and forwards it only to other VLAN 10 ports. Finance never sees it. IT never sees it. That data stays entirely within VLAN 10. What if someone moves from HR to finance? Do you rewire anything? No. You log into the switch and change the port assignment in software. Done. No cables. Just a configuration change. What if HR needs to send something to finance? That's possible, but only through the router. The router sits above the VLANs and routes traffic between them when configured to do so. This is called inter-VLAN routing. The router is the controlled gateway, and you decide exactly what crosses between VLANs. Why do network administrators love VLANs? 4 big reasons. 1. Security. VLANs isolate sensitive traffic. HR data, payroll files, executive communications. They stay within their own VLAN, invisible to the rest of the network. This is fundamental to network security architecture. 2. Performance. In a flat network, broadcast traffic goes to every single device. With VLANs, broadcasts stay within each VLAN. Smaller broadcast domains mean less noise and a faster network. 3. Flexibility. Move someone to a new team, reassign their switch port in software. VLANs can span multiple buildings through trunk links. No rewiring. 4. Cost savings. Before VLANs, separating 3 departments meant 3 physical switches. With VLANs, 1 managed switch does the job of all 3. Security, performance, flexibility, cost savings. That's why VLANs are standard in every enterprise network on the planet. Quick knowledge check. 3 questions. Pause after each one if you need time to think. Question 1. An HR employee's computer is on VLAN 10. Which devices can it directly communicate with? A. All devices on the switch. B. Only other VLAN 10 devices. C. Only the trunk port. D. Only the router. The answer is B. Only other VLAN 10 devices. Access ports restrict traffic to their assigned VLAN only. Question 2. What is the purpose of a VLAN tag or 802.1q tag? A. Encrypts the data. B. Labels the packet with a VLAN ID so the switch knows where to send it. C. Speeds up delivery. D. Assigns an IP address. The answer is B. The 802.1q tag is a 4-byte label identifying which VLAN a packet belongs to. Question 3. Which type of port carries traffic from multiple VLANs simultaneously? A. Access port. B. Management port. C. Trunk port. D. Uplink port. Let's bring it all together. 5 things to remember. 1. A VLAN logically separates a physical network into isolated segments. Same hardware, multiple networks. 2. VLAN tagging. The IE 802.1q standard adds a 4-byte label to packets so the switch knows which VLAN they belong to. 3. Access ports connect one device to one VLAN. Trunk ports carry multiple VLANs between switches and routers. 4. VLANs deliver 4 key benefits: security, performance, flexibility, and cost savings. 5. VLANs communicate with each other only through a router, a process called inter-VLAN routing. If you understand those 5 points, you understand VLANs. That puts you ahead of most beginners. If this video helped you, hit the like button. It helps this channel reach more people who are learning networking and cybersecurity. Subscribe to 3V Learning Center so you don't miss what's coming next. In the next video, we're covering inter-VLAN routing, how a router allows controlled traffic between VLANs, and what a Layer 3 switch is. Drop your questions in the comments. I read everyone. Study resources are linked in the description. Until next time, keep learning, keep building. See you in the next one.